Hello viewers, welcome to yet another episode of Continuing Professional Development. Continuous is a buzzword that is associated with everything around us. It is students' learning which needs to be continuous. Advancement of technology also needs to be continuous. Similarly, we teachers can also be not left far behind. We also have to have a continuous professional development. And the necessity of such professional development has gained immense importance after the introduction of NEP 2020. During the COVID time, we have realized as teachers, how can we upskill our teaching capabilities? What extra we need to learn so that the teaching, learning is productive. So today's session is based on that. Here in this session, we are going to discuss what are the demands of NEP 2020 for having a productive teaching learning situation. NEP 2020 demands that every teacher must be a digital teacher, having adequate digital competency so that he or she can integrate technology in the real classroom situation. The teachers must be tech savvy. They should also develop within the students the habit of experiential learning. So today, we are going to discuss one specific tool in the teaching and learning of the subject mathematics. Now, as teachers, we may ask ourselves, why do we need to use tool to teach maths? We are very comfortable using chalk and talk method. But our chalk and talk method is limited to a particular point. We cannot go for more exploration using chalk and talk method. So these digital tools which are available helps us in many ways. The three most important factors in the teaching of mathematics using digital tool. First point is visual learning. Now, in the visual learning, you can see researchers over the years have found out that learners learn easily when represented facts visually than text alone. Visual representation also gives you the idea to explore various mathematical concepts. Now, using this visual representation, a learner can manipulate the geometrical figures, the shapes, and can experiment with many other properties, concepts, ideas of mathematics practically. The second point, which is very, very important, which is not possible always in a chalk and talk method, is the interactive engagement. Now, interaction is a very key factor in the teaching of mathematics. If there is no interaction in mathematics, there can not happen any learning in mathematics. Interactive platform gives the students the scope to explore different mathematical concepts. Hands-on approach is very engaging and enjoyable for the learners. Interactive learning also gives opportunity to students to do a lot of experimentation and plenty of exploration. And the third and the final point that is required here is conceptual understanding. Maths is a subject whose interest and beauty can only be understood if we have understood the concept underlying the principle of maths. Now, to understand this conceptual topic from mathematics, what these digital tools they do? They bridge the gap between the theory and the practical application, where the learner can see by themselves how this theory, when converted into practical form, how important or useful it becomes. It also connects all the branches of mathematics. And conceptual understanding gives us a very clear concept of what should be done for the holistic development of the learner. Now, we have seen what are the three crucial factors or the key factors why you use digital tools for teaching of mathematics. We have many tools available nowadays, but today I'll go through three tools, and in the second session we'll work on only one tool, because we need to learn one tool and then extend our concept, idea, learning to the other tools. All the tools will be in one way or the other way related to each other. Now, the first tool that I like to discuss is the tool known as Desmos. It is an online graphical calculator which is very much useful in drawing of graphs. It can be used in your computers, in your tablets, with internet. It can also be downloaded to work in the offline mode. Desmos is available in multiple languages. One special feature of Desmos is that it is helpful even for visually challenged learners. The second tool that I'd like to introduce you to is by the name of RoboCompass. From its name, RoboCompass, we understand that it has something to do with geometry. It is one of the most important and useful digital tool for mathematical construction. RoboCompass is available online, and it also has 3D geometrical figures concept. RoboCompass allows students to create animations of all geometric constructions, conic sections, whatever comes in geometry construction part. And the third and the final that we are going to discuss here is GeoGebra, the ultimate digital tool in the teaching of mathematics. It is free, open source. It is very dynamic. It has multidisciplinary tools, very user-friendly, and it actually covers geometry, algebra, and statistics. By the name GeoGebra, we understand it is the integration of geometry and algebra. Now, how do you download GeoGebra? Now, GeoGebra has various versions, but The most popular version is GeoGebra Classic 5. You can work online, you can work offline, and it is compatible with all the gadgets that are available with us. When you download, you will have to download it from the official website, geogebra.org/download. And once you have downloaded, then whatever dialog box appears, you just have to follow that and install GeoGebra in your system. GeoGebra, once you start using GeoGebra in your classroom, you will understand the inquisitiveness of the students. They would love to know more using the app or the tool GeoGebra. Now, it is not the end. We don't have only 3 digital tools. There are many free open source ICT tools used for teaching and learning of mathematics. Name of few I have already listed: Sage Math, Tux Math, Octave, Maxima, GNU Plot, Khan Academy, and Skylab. You can go through all these to check which one is useful for you. But one thing you should make sure, one particular tool you should practice is very, very properly, so that you will be able to use the same experience in the other digital tool platforms. All right? So in the second session, we'll be doing few geometrical theorem proof of those using GeoGebra, and how GeoGebra can help simplify the illustrations of geometry in real classroom situations. Welcome back, viewers, to the second session of using digital tools for teaching and learning of mathematics. As you can already see on the screen, I have mentioned hands-on with GeoGebra. That is, how do we use GeoGebra in teaching learning situation? Now, when you download GeoGebra app, you will see that it has a menu bar. That menu bar has 7 options, and you can see clearly the options. File option is there, edit is there, view is there. Every option also has a drop down where you'll get few more options to explore. Another tool that we have is the construction tool. Now keep this in mind: when you download, your construction should have 11 parts. One part will be move, then you have point, you have line, you have angles, polygons, and so on. There will be 11 options, and every option will have a drop down. From those drop down, you will get plenty and plenty of options for your each and every part of geometry that is required till the secondary level, even higher secondary. While dealing with GeoGebra tool, there are a few points that you as a beginner should remember. Whenever you open that GeoGebra tool, you will see that it comes with 2 windows. One will be an algebraic window, the other one will be a graphic window. We have other options also, but usually when you open, there are 2 windows that comes. Those windows will actually help you to understand how algebra is directly related to geometry. So that connection between the branches of mathematics can be developed very easily. Second point you need to remember is that in GeoGebra, you have an input bar at the bottom, left-hand side bottom. While doing demonstration, I'll show you how can you use those input bar. The third point that you need to remember is that in GeoGebra, every point can be moved, but not the dependent points. What do you mean by dependent points? Suppose you find the midpoint of any one line segment. So for line segment, the endpoints are not dependent, but the midpoint is dependent. So you cannot move that midpoint, but you can definitely move the endpoints. In GeoGebra, you always have to measure angle in the clockwise direction. If you measure the angle in the anti-clockwise direction, you will get a reflex angle. One thing good about GeoGebra is every option, when you take your mouse to that particular position, you will see that it actually guides you what needs to be done, what should not be done. Clockwise, anti-clockwise is in the same way. The moment you go to angle, they will tell you how do you identify the angles. Now, if you are dealing with angles and you want to move a particular point, what you need to do, you need to press escape or go to the move button so that the highlighted option gets changed. So if any highlighted tool, if you want to change it, either you press escape, ESC, on your system, or you go to the move option, the very first tool from the construction tool. And last, right clicking on the graphics view. Once you right click, you will get the axis out. That means there will be no more axis. Again you do that, right click, and then you get the grids out. So once your grids and the axis are removed, the space that is available can be used as a whiteboard. So there is another facility option that GeoGebra has. Now in today's demonstration, we'll specify few properties of geometry. As a teacher, we have always faced difficulty to explain to the students each and every criteria related to geometry. Because when I say, for example, the sum of all the angles of a triangle is 180 degree, the students may not agree. They would like to explore more. They would like to draw different types of triangles to see whether the statement is true or not. So in our second part, hands-on, when I'll start with hands-on, we'll check each and everything, and you can see for yourself that each and every student in the class will get an idea, yes, sum of all the angles of a triangle is 180 degree. Then you can also show to them that angle subtended by the circle at the center is twice the angle subtended at any other part of the circle. What our students face difficulty, if the figure is same, they can remember the result very, very easily. But if the figure is changed or there is little bit of modification, they are not able to understand which theorem they should apply. But using GeoGebra, that difficulty is going to be removed. You can also try exterior angle property of a triangle. We will do also constructing a rectangle using a circle. How can you construct a rectangle with the help of a circle? And the last is using slider tool, we'll try to construct polygons and generate few interesting designs. Those interesting designs will lead students towards exploration, experimentation, and learning new concepts related to mathematical principles. All right? So dear viewers, now I have taken you all to the page of GeoGebra Classic 5. Now see, as I have already mentioned, you have 7 options. Right on top you can say you have File, you have Edit, View, Options, Tools, Window and Help. Below that, you have 11 options. Those are known as construction tools. Then we have 2 windows. This is the algebra window and the other one is the graphics window. The algebra window is on the left of your screen. The graphics window is on the right. Come down, you will see that input is written. Now in that input, if you see that bar, it is totally empty now because we have not yet started with anything. As we start, you will be able to see what is going to come. I'm not going to tell you in advance what are the things going to come there. Now here, let me start with one particular experiment or demonstration. And the first demonstration for today that I have fixed is angle sum property of a triangle. Okay? So what we need for angle sum property of a triangle? We need a triangle. And a triangle needs 3 points. So we choose 3 points first. So I go to the point tool. Can you see the drop down? It has a point. It has a point on an object. It has attach and detach point, intersect, and similarly the others. Midpoint. Can you see midpoint or center? That is what I told you. It's a dependent point which cannot be moved. So similarly, all tools will have few drop downs, and from those drop downs we choose the appropriate option that is required for us to teach that particular topic. Now here I need to take a point. So what I do? I take a point. I mark a point here. I mark another point here. And I mark another point here. Can you see in the algebraic view, the coordinates of A, B and C are given? Have you ever realized that what are the coordinates here? 3.2, 1.95, which is impossible for us to teach or draw it in the blackboard. So GeoGebra takes into account all small details regarding a particular point. Now we have taken 3 points. Now our duty is to draw a triangle. Means we need line. But it is not line, we need line segment. So you go to the third tool from construction tools. You can see line, you can see segment. If you look at those drop downs, you actually get a clear picture. If you take line, that line is going to pass those 2 points. If you take a segment, it is going to start from one point and go to the other. So looking at whatever is given there, you choose accordingly. So here in this case, we choose our line segment. Now we join. Now after we have drawn the 3 points, now our duty is to join. So in the line, we take line segment, we start from A and join B. Got it? Same from B, we take it to C. And then from C, we take it to A. So you've got a triangle. What is our aim? Our aim is to show that sum of 3 angles of a triangle is 180 degrees. We have not yet measured the angles. Now you want to change, you want to move this figure, go to the move graphics view and you can move this so that you are at a comfortable position. Now this is on angle sum property. So but I have not mentioned anywhere angle sum property. So if you want to mention angle sum property here, what you will do? You will go to the 10th tool of the construction. There you will see that text ABC is given. You choose that and just click anywhere. And then here you add what you want. Angle sum property. And then just press OK. This has come here. So now I know that what I am going to do. You want to beautify this, right click, shift it here, and then if you want to do some arrangement here, you can do that also. Symbols, objects, everything is there. So you can make it beautify that angle sum property so that it looks attractive. Now, I have to measure the angles. So what do? We go to the angles part. Now when you go to the angle, there are so many drop downs. Angle, angle with given size, distance or length, and so on. So kindly explore this tool. You will be knowing many extra things and how to use them so that your topic gets covered easily. So here I take angle and I choose 3 points. There was an instruction given for angle. I have not read that instruction. Let's see what happens. A, I have chosen. B, I have chosen. C, I have chosen. What? What angle we are getting? We are getting 310 degree. It's a reflex angle. That is what we are not supposed to do. So that means I have measured the angle in anti-clockwise direction. Whereas in one of the slide, I have specified that you have to always measure angle in clockwise direction. So I need to remove this. So just press Ctrl Z, it gets removed. Now again, you go to the angle option and now you choose C, then you choose B, and then you choose A. What angle you are getting? 49.99, correct? Next, you choose B, you choose A, you choose C. What angle? 61.11. And finally, I choose A, then C, and then B. I have got an angle. But these angles, I have to make it little bit clear because 61.11 is lying on top of the figure. I have to bring it outside. So you go to move and then simply move that. Can you see beta has come out? Gamma has come out, and your alpha has come out. Now you can see very clearly that what is the value of your alpha, what is the value of your beta, what is the value of your gamma. What we have done, just if you go back again, after you open GeoGebra Classic 5 homepage, you will see the menu bar along with the construction tools. Since our aim is angle sum property, so we have to draw a triangle. So for that triangle, I need 3 points. So the first thing that I did was I have taken 3 points, A, B, and C. Then we joined them using line segment. After joining those, we have seen that the angles are not yet determined. So we keep in mind that angles must always be measured in clockwise direction. So we have measured in the clockwise direction and we have got. Now viewers, you must be worried that how do we show that sum of the 3 angles of a triangle is 180 degree? Because here 68.89, 61, 49.99, lot of addition, subtraction is required. So now what do? We go to the input button, down. Can you see the input button? I have pressed in that particular bar. The cursor is there. I write sum, SUM sum, equal to. Now you see in the right hand side of this input bar, you can see alpha, beta, gamma, everything is coming. So you take alpha because one of your angle is alpha. Then plus, then you take the second angle which is beta, again plus, then you take the third angle which is gamma. So that means you have taken alpha, beta, gamma. So in the input bar, you have written sum equals to alpha plus beta plus gamma. Done? Now just press enter. What you have got? Can you see in the algebraic view that sum is 180 degree? Now for students, you can demonstrate it by moving the triangle so that every type of student in your class can get an idea that it is not limited only to a particular specific figure. Because in class when we teach, we can at the most draw 2 to 3 triangles. But here we can draw infinite number of triangles and we can show. Now see, this is how you demonstrate. You go to the move button, go to point C or any point and just change it. See, this triangle is changing in various directions. But can you see in the algebraic view? Just look at the algebraic view. Everything is changing. But what is not changing? The sum is not changing. That means we can tell our students that sum of any 3 angles of a triangle is 180 degree. But you cannot bring it down. See? Why? Because you are getting a reflex angle. The property is not true for a reflex angle. So you just have to take it on top. Correct? So this is how you can demonstrate in the class that angle sum property. Keep in mind what are the things you are doing and how you are demonstrating that. Is it okay? Now, after angle sum property, we'll go to a property or a theorem from circle. We can cover many more things, but when we start with a particular app or a tool, we should limit ourselves to few concepts just to get an idea of how the construction tools are behaving, what are the options that is available to us, and then you can keep on exploring. Now, I'm not going to save this project. Now, we come to a new project, which is angle subtended at the center. So I write here in the text, angle subtended at the center is twice the angle subtended at any other part of the circle. Angle subtended at any other part of the circle. Fine? See, angle subtended at the center is twice the angle subtended at any other part of the circle. Now, that means what is required here? You want to shift this, so you take it on top little bit. So the topic is right on top. You want to remove the axis and the graph. Remove, right click, as I have written in remember. Remove. Again right click, grids. Now see, it has become a whiteboard. So this is how we do our entire construction, right? Now let's start with our circle. So we go to the circle tool. From that circle tool, I take a circle with center through point because I don't want to specify any particular radius. So I've taken a circle. Let us take this. Now I want 3 points so that I can connect them to the center of the circle. So go to the point. I've taken a point C here. I've taken a point D here. I've taken a point E here. Fine? Let me just go back. How did we start? We started by writing angle subtended at the center. How do you do that? From the 10th construction tool of slider, you will see that option text. The moment you click on text, a dialog box appears. You enter the text that you want and then just press OK. It will come in that particular screen. After that, what I did, since I am dealing with a circle with no radius, so I went to the construction tool dealing with circle and I took the first option and I have drawn a circle. Now, whenever a circle is drawn, you will see that always that C comes. C means it's a circle, A is the center, and there will always be another extra point so that to get the radius of that particular circle. But here what we have done, we have taken 3 more extra points as in C, D and E. Now we'll connect, we'll join them. So again, you remember it should be a segment, it cannot be a line. So you join A and C. Then you join A and D. We join C and A. and we join D and E. Done? After that, what we have to do? We have to measure the angle. So you go to the angle part. You choose these angles C, E, D. Have you seen? You have got an angle. The measurement of which is not very clear, we'll remove that. This is what we will be learning slowly, slowly. How do you move things which are not clear outside the figure? Next we take C, we take A, and we take the third point. Now let's see what are the angles. Is it twice? That we have not checked till now. So what do we do? Since it has not been checked, I'll go into the input bar. There I'll put alpha, because alpha is 2 times of beta, or beta is 2 times of alpha. So you first check, this is beta, and on top you have alpha. So go to this, take beta equal to 2 equal to 2 alpha. Equal to and 2, I have used my system. Beta and alpha, I have used the input options that is available with you. After you have written beta equals to twice alpha, just press enter. See what has happened. Can you see in the algebraic view, 119.2 is there? That is twice of alpha. Now let me just make this, move this point. Which point can I move? I can move C, I can move D, I can move E, I can move A. How do you know what can be moved? If you are not doing any color combination from your side, you are not trying to beautify anything, then everything that is marked blue can be moved. And if you are using some colors from your side, then you have to remember which color you are putting where. By default, blue color is the color which can be moved. Any other dependent points cannot be moved. Now see, I have done this. Now I keep on changing E. Now see everything, see on the right hand side or on the left hand side of your algebraic view, you can see that things are changing. But is the angle beta changing? No. Now let's see this. See, whatever we do, it will always remain twice. I'm changing this now. I'm changing this. So this way, your students can get a very good and clear picture of different types of figures, geometrical figures based on circles, based on triangles. As a teacher, and when I was a student, we always had difficulty in finding the similarity between what is there in the theorem with what is there in the textbook or the question paper. We never had tools like GeoGebra to check and verify. Now we have tools like GeoGebra where we can tell our students, and we can also demonstrate in our class the different ways of dealing with it. And the properties of maths, which had a lot of abstractness, can now be made clear to the students. Okay? Now, we'll go to one more property, and which is slightly different because I'll be using one particular tool. Till now, I was dealing with geometry, pure maths concept. Now, we'll be doing a particular tool which is usually very, very important when you are dealing with polygons or many things, many extra things also. And that is slider. So I'll just go to text and then I'll just write here using slider. Using slider. So that you know how sliders can be used. Again, let me tell you, we have just started using the tool. Slowly, we'll be able to get a good concept good experience, and then we can use the other options, other tools, other properties. Now, to use a slider, what I do is that I choose a line segment of a given length. So I start from A, and then length, let us take it as 4, and then OK. So now see, earlier I joined 2 points to get a line segment. Now I have taken the help of that option where the line segment of a specific length is already mentioned. It can be degree 3, length 3, 4, 5, whatever. Now I want to introduce a slider. So what I do, I go to that slider option and I take a slider. I click on that graphics view, I take integer, and here I write it as n. Here by default n has come, and see, it is from minimum 1 to maximum 30. These are the values it can take, and there will be an increment of 1. As you deal with sliders where number is going to be required, where angle is going to be required, where integer is going to be required. So all the options are given to you. Here I have taken integer going from 1 to 30. Now let's see how it works. See here, this is a slider. Slider means shifting value of n from 1 till n equal to 30 as we have already specified. Now if n is 1, there is no change in the figure. I take n to 2, still there is no change. I take n to 3, I take n to 4, no change. So what has happened here? Why the slider is not changing? Because when I go to this particular AB, I have to specify what I need to do here. Because here I have just defined the slider. I have not done anything. I want what figure? When n is 30, n is 24, what type of figure we'll get? Indirectly, what type of polygon we'll get? So we want a polygon, so we go to polygon. We want a regular polygon from A, B. Now they have asked how many vertices you need. So now I remove these and I write n vertex. OK. Now as n equals to 1, there is no polygon. Even in our maths we know n equals to 1, no polygon. N equals to 2, no polygon. N equals to 3, what are we getting? We are getting a rectangle. We are getting a triangle. 4, rectangle. 5, what do we get? Pentagon. 6, hexagon, and so on it continues. Now see, as you increase the value of n, your polygon, so many different shapes are coming. Now, you want to reduce, you can zoom in, zoom out to see the beauty of that figure. The more you do this, you come to a circle. So that means slider is used to make a particular figure, not limited only to 2 or 3 or 4 sides or 4 angles. If you have to expand the concept beyond 3, beyond 4, slider is the best option. So as teachers, while teaching geometry, you know where the option of sliders are going to be very, very helpful and useful. So now see, here we are not going to verify anything as in the last 2 cases. Here I just wanted to show you how can you use slider. How did you use slider? And what difference does it make when you use slider? How the figures changes. So students can really enjoy when they keep on shifting the value of n, they can see how the figure is changing. That will create a lot of excitement, they will enjoy, and it will be very engaging also. Now the last one that I'll show for today's session is to create more excitement in the classroom. And this generation of kids are so much oriented to technology through mobile or any other gadgets. So what I'm going to show here now will really give them a lot of interest. We all have heard about screensavers in mobiles. How do that design are generated? So those designs can be generated by your students using this app GeoGebra. So let me just demonstrate one particular screensaver. So what do we do here? We get rid of the right click in this particular, get rid of the axis, get rid of the grids. Okay? We take polygon. What polygon? We take a regular polygon. Of 4 sides. Fine. So I've got this. Now what I'll do here is that I want it to generate a design. So I'll choose any one of the point. I'll choose a point B. So I click on that point B. And then I choose, okay, I have clicked on the point B, but that mistake I have made. Can you see? I have made that mistake that I wrote in the remember. That if you have to do something, you have to come out of that highlighted option. Here the highlighted option is this, regular polygon. So I need to come out of that. So what do? I press escape. Alright? I press escape, I have come out of it. Now, what I'll do, I'll choose a particular point. What I'm trying to do here, I'm trying to show you a little bit of rotation about a particular point. Rotate about a point. B is the point that I have chosen. The figure that I have chosen is that quadrilateral. Rotate what? Angle 45 degree counterclockwise. Let me press OK. See what I have got. Again, let me choose the same point B and choose this quadrilateral now. Again 45 degree. OK. I've got another. Let me choose B again. Again, let me choose that particular portion. Again 45 degree. Another. B again. Quadrilateral again. Again 45 degree. B again. Again this quadrilateral. We get another. Now, how can these designs be framed? I have taken a regular polygon. Now, how can this? See here. If I keep on moving this, what are the different types of figure you can do? With regular polygon, we have some limitations. But with irregular polygon, many things can be done. So here, this is one simple example, which is not a particular very attractive design, but it actually will give you a lot of idea to the students and they can generate many more such. Let me just remove this entire and let me remove this point also and show you how you can make it even more beautiful if you are using not regular polygon. Take points. Alright? Now I want what? See here all the points are not dependent. So that means every point can be moved. Now I take, rotate about a point. I take that point and I mark this quadrilateral. So I get this 45 degree. Press. Again you take that same point C, mark that 45. Again that point C, mark that, okay, 45. Again that point C, the point should be the same point, you cannot keep on changing. Again that point C, mark that last obtained quadrilateral. Again that point C, mark that, the last one. Now see, if I move now, what happens? So these are different type of designs which actually helps students to develop interest towards the subject. They will get enough opportunity to experiment and explore. Okay, thank you viewers. I hope the session was fruitful, meaningful, and we can learn and make our students learn subject maths with lot of interest and enjoyment. Thank you.